Sure. Okay, well, my name is Lotfi Zadeh, and it's my great pleasure to be here at NIH in this mecca of medical science and to respond to questions that Carl may pose to me.
Thank you, sir. I appreciate you coming. It's great that you're here. All right, well, our audience is mostly interested in robotics, and your contribution in fuzzy logic and engineering and systems analysis is tremendous. How do you think the future of soft computing and fuzzy logic could be applied to robotics?
Well, in the first place, thank you for the compliment. Now, of course, it shouldn't come as a surprise if I say that yes, I believe that fuzzy logic has an essential role to play in moving toward the era of machine intelligence, automated reasoning, and especially in the realm of robotics. Now, when we come to robotics, then there are two issues involved. One is in building a robot, and the other one is communicating with the robot. So let's assume that we have a robot, and this robot has certain capabilities, speech recognition capabilities, and so forth. Now the question is, how do you communicate with the robot? Now, I'm talking now at this point in terms of what I called human-machine communication. It is the sender is a human, the recipient is a machine. How can a machine understand what you say? So, fuzzy logic is what is needed to develop a capability for what I call precision of meaning, and more specifically, precision of the kind that results in something that the machine can understand. Humans can understand unprecisated language, natural language. Machines cannot do that. So you have to do something, and that's where fuzzy logic comes into the picture, that would make it possible for a machine to execute instructions expressed in a natural language. So, for example, take a few steps. That's very simple. But human can understand that, machine cannot understand it, because machine doesn't know what do you mean by few steps, you see. And so that's where the concept of precision comes in the picture. Fuzzy logic is a meaning precision language. That's really what it is. And so it can play an essential role in making it possible human-machine or human-robot communication.
So, from what I've seen so far, when you speak of precision, it's about taking maybe concepts that are described in human terms that are kind of vague, like, pick up, have a seat in that chair. To get a machine to understand the concept of what a chair is a very challenging thing. So, if we're talking about precision, I really want to focus on that term. Is it about a dialogue between maybe the information that's coming into a machine and the human describing it? For that example, chairs are very abstract things. And to try to get a machine to understand, this is a chair, how would a dialogue, or how is precision a part of describing it?
Yes. Well, what is not involved in this sort of a thing is clarification, back and forth discussion. You would say something, and the machine says, well, I didn't quite understand, this and that, will you please explain it? It's not that sort of a thing. It's a sort of a thing where the sender, human in this case, says something, and it is said in a precisated natural language. The kind of language that a machine can understand. It's precisated natural language is a form of natural language machine can understand. That's what it boils down to. Now I must tell you that this is used in almost all applications of fuzzy logic today. It's not something that's going to happen in the future. So take, for example, fuzzy logic transmission, automobile transmission, which is used now in most cars. Now, the design of transmission comes up with a bunch of instructions, in effect telling in a natural language, to begin with, to the machine, to the transmission. If this happens and that happens and so forth, then do this and that. Then that is precisiated, you see? So then it's translated into a language which the transmission can understand.
And right now that's
And that is done right now.
mathematical,
That is done right now.
Mhm.
That's done right now.
But that language that the transmission understands, is that a computer program? Is that an equation? You know, right now it's being translated.
Well,
What's the principle?
well, the first part of it involves fuzzy if-then rules. And then those rules are translated into some programming language.
Gotcha.
But so the first thing is natural language. The second stage is language of fuzzy if-then rules. And the third stage is where it is translated into programming language or some machine, whatever, some language that a computer or fuzzy logic something can execute. So they use fuzzy logic chips to do that sort of thing. Yeah. So what I'm talking now is something that will be more sophisticated, you know, not just fuzzy logic transmission where this is built into a design of the transmission, you see. It's done, period. Now we are talking about situation where we have a robot, different circumstances, different environment. You give an instruction of some kind. It may be a high-level instruction, like park the car. It's high-level instruction. And then, so that instruction is executed. Okay. I think that the use of fuzzy logic is a necessity. It's not an option. Because natural language is imprecise. As I said earlier, humans can understand unprecision natural language. Machines cannot.
All right, and lastly, we have a lot of young folks that are interested in robotics and
Yes.
you know, maybe going into the
Yes.
career of machine intelligence in the future. Do you have anything inspirational to say?
Well, what I want to tell you is this, that some of the ideas, you know, that I have been sort of advocating have found a warmer welcome in other countries, other than the United States. So, for example, in Spain, certainly in Spain they have established now a European Center for Soft Computing. Fuzzy logic is part of it. But in addition to that, there's work being done in various places where and also in Japan, called perception-based robotics. Yes, humans can do all kinds of things based on perceptions. You drive a car, you juggle, you play basketball, whatever, based on perceptions, not measurements. At this point, robots do not have that capability. So when you add that capability to whatever a robot can do, then you call it perception-based robotics. Now, if you use Google and put perception-based robotics, you'll find quite a few papers. Unfortunately, most of that work is being done in Japan, Spain, and some other countries, South Korea, some other countries. Perception-based robotics. So people working on it. The simplest form of it, when you have a robot and you issue instructions in a natural language, move a little to the left, move a little to the right, you know, so instead of doing it yourself, as crane operators do, you know, you have oral instructions expressed in a natural language, which then machine executes. So imagine a crane which operates in that fashion. So we have somebody who looks around, says, lift this thing a little bit, move to the left, to the right, you know, whatever the case might be. Yeah. And now, as an illustration of the power of natural language, you could do the following. You could take a car, blindfold the driver, put a passenger next to the driver. The driver will be guiding, the passenger will be guiding the driver. So it's slow down.
Words only. Just
words only. Slow down, turn a little to the left, or there is a car on the left, move away, do that, so forth. I wouldn't want to do it in heavy traffic,
No.
but you can see that that can be done. The power of natural language, just a few instructions, sufficient. What happens? You filter out decision irrelevant information. You focus only on that which is necessary. You don't say there is a green car on your right. That's a capability. So when I look at some of these books on AI, even the popular ones, unfortunately, they don't stress those things. It's not part of the sort of traditional view of AI. So what I'm saying is a non-traditional view. It's a view that stresses the need for understanding of how humans function, human-level machine intelligence, which are altogether different sort of thing.
Very good. Well, thank you, sir. I appreciate you taking the time here.
Thank you so much. It's a great pleasure.